Hello everyone. Today I'm going to show you how I transform an ordinary old circuit breaker and a few simple components into something truly remarkable. You might think this device is only good for the scrap heap, but in just a few minutes, I'll turn it into a versatile tool capable of doing tasks you wouldn't expect. My goal is to repurpose its robust internal components, so I'll start by carefully opening up the casing. I carefully open it up by removing these screws. With the screws removed, I'm now carefully separating the outer casing. This reveals the internal structure, including the basic mechanism and the contact points. I'm going to use my screwdriver to remove these screws one by one. It's important to keep track of all the small parts during disassembly to ensure everything can be put back together later, or to simply ensure I don't lose any critical pieces. As I continue, I'm extracting a few more small pieces, like these washers and nuts, along with some of the original wiring. Understanding how these parts fit together is crucial for successful reassembly, even with our modifications. Now that I've completely disassembled the main circuit breaker unit, I'll take these pieces of insulated wire. This wire will serve as a primary connection point for the modified circuit. Proper stripping ensures good conductivity and reduces resistance. Once the wires are in place, I'm securing them to various points inside the structure. This is to create a regulated electrical path for our new gadget. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Don't forget the nut you just removed. Now I tighten the terminal screws to secure the wires to the circuit breaker. Then I carefully route the wires to avoid affecting other components. Good wire management is key to preventing short circuits. Following the same process, I'm attaching a second wire to another terminal and tightening it. Precision here ensures good conductivity and safety in our finished product. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm making sure to tighten the screws securely to ensure a strong electrical contact. This is forming the internal circuit for our new tool. I'm stripping more red and white wires now. These will be used for the power input connections and for creating the custom tips for the tool. Now I'm connecting one of the stripped white wires to a terminal on the fuse holder, securing it firmly with the screw. This will carry the power to our device. Next, I'm attaching another red wire to the adjacent terminal, tightening it down. These two connections form the primary power input for our repurposed tool. I'm stripping the insulation from a set of red and white wires. To make this tool incredibly versatile, I'm attaching alligator clips to the external leads. These clips allow for quick and easy connection to different power sources or tools. I'll repeat this for the second long wire. Remember, red for positive, black for negative. Now, I'm carefully closing up the circuit breaker casing. All the modified components are neatly tucked inside. Next, I'm preparing another wire, a red one, to connect to a different output terminal. This will provide a separate access point for various electrical tasks. This step expands the functionality of our repurposed breaker. I'm preparing white wire. Making sure the insulation is stripped cleanly is important for a good connection. Carefully tightening each screw. These will be the leads for the internal fuse, connecting it to the main circuit inside the holder. These are crucial for the fuse to function correctly, acting as a safety mechanism for the entire circuit. I'm reattaching the plastic cover, making sure it sits flush. The goal here is to keep the new internal wiring secure and prevent any accidental contact once our project is complete. Now, with the housing closed, you can see the wires extending out from one end. Next, I'm preparing another wire, a red one, to connect to a different output terminal. I'm attaching alligator clips to the external leads. Make sure it is tightly connected. Our next key component is this spark plug. It has a ceramic insulator and a central electrode. Perfect for our purposes. This connector is the key part for the heating element. I attached the connector to the end of the spark plug, securing it securely with a screw. I'm securing it in place with a screwdriver to ensure a good electrical contact. Similarly, I used white wire strippers to expose the copper wire. I split the copper wire into two parts and twisted them together in preparation for the next connection. I connect the spark plug to this wire, creating a small, portable heating element, perfect for quick soldering jobs. Using pliers, I twisted the copper wire tightly to secure the spark plug securely. Once the wire is securely attached, I'll use electrical tape to insulate all exposed connections on the spark plug assembly. This is vital for safety, protecting against accidental shorts and ensuring the tool functions correctly. Next, I'm crafting the core of our new versatile tool, a heated tip. I'm taking a standard AA battery and carefully peeling off its outer plastic casing. The goal here is to extract the carbon rod from the center. After completely removing the shell, I will use a box cutter to cleanly remove the plastic layer on the battery. Then, I use pliers to carefully remove the metal positive terminal cap from the top of the battery, then pliers to gently pull out the carbon rod. To ensure maximum efficiency and conductivity for our tip, I'll clean the exposed top of the carbon rod thoroughly with paper. To make our carbon rod tip precise and effective, I'm securing it into a drill chuck. Then, using sandpaper pressed against the spinning tip, I'm refining it. This ensures a clean and effective tip for our new tool. Once I'm happy with the sharpness, I remove the rod from the drill. Once sharpened to my liking, I'll remove the carbon rod and insert its unsharpened end securely into the spark plug connector that we previously prepared. Using a screwdriver, I tightened the screw to ensure the carbon rod was securely installed. I added an orange clip to the spark plug to make a handle for my welder. Now for the moment of truth. Here I have a small 12-volt battery. I'm connecting the alligator clips to a battery. Watch as the custom soldering tip heats up, glowing bright red. This demonstrates its immediate functionality as a portable soldering iron. Amazing, right? But when I disconnected the breaker, The soldering iron did not work immediately, proving that this improvement does not take away from the original nature of the breaker. For the first test, I got an eye bolt. I clamped the alligator clip to it. I will attach this washer to the eye bolt by welding. When I connect the circuit, the metal heats up rapidly and intensely, glowing bright orange and even sparking. This immediate and localized heat generation is perfect for tasks like soldering, brazing, or controlled cutting of small metal pieces. You can actually see the metal beginning to melt and glow with incredible intensity. This shows how our simple circuit breaker has been transformed into a powerful portable tool for various metalworking tasks. Now, I'm going to join these two small wires together using our new tool. By briefly touching the superheated carbon rod to the ends of the wires, you can see them instantly melt and fuse, creating a strong and clean connection. It's surprisingly effective for quick electrical repairs or even delicate crafting projects, far beyond what you might expect from an old adapter. This setup is incredibly versatile, and it's not just for welding. Finally, for our third test, I'll be attaching this multi-tool knife with a bolt together. As the current passes through, the carbon rod heats up intensely, glowing a bright red. This creates a powerful and precise hot cutting tool. Here's a closer look at the soldering in action. You can clearly see the solder melting and flowing, demonstrating the precise control and heat this device provides. It's just incredible how a simple component can become such a capable tool. Just look at the sparks flying as it melts metal. A humble circuit breaker, transformed into a multi-purpose powerhouse. We've seen it power a circuit breaker, heat a glow plug, ignite a heating element, and even perform controlled metal heating and cutting. This project truly unlocks new potential for everyday components. If you enjoyed this amazing transformation and found this DIY project inspiring, please give this video a big thumbs up. Don't forget to share it with your friends who love creative hacks and practical solutions. Your support helps me create more content like this. Thank you for watching, and I'll see you in the next one. Bye.